Hello, my name is Joaquin Romo. I work for the analog division of Freescale in the group of PMMC, Power Management and Motor Control. I am here to introduce you our new power supply, the MC34717. This is a dual channel power supply with capability of 5 amps of current on each channel. Okay, first of all, I want to tell you the target application of this part. The target application are networking, communication, consumer and industrial. But for this time, we are going to show it on a lighting demo. You might ask yourself, why a lighting demo? Well, first of all, I want you to think in the power supply and not in another thing. Yes, normally when you see something working, you think on the microprocessor, you think on the motor, you think in other things, but you don't think on the power supply. So right now, by using lighting, you can see it, but the only thing you really think about is the real basic, power management or power supply. Okay, so let me tell you right now, we are using our board to supply current to these two internal boards. Okay, the first one goes to the logo and the second one in the banner. Yes, we are driving high brightness LEDs. For the first one, 16 of them, and in the second one, 10 of them. These LEDs have a forward current of 350 milliamps each, and they are all connected in parallel. So we need a low voltage and a high amount of current to drive the full board. Okay, well, let's put this in the side. And well, let me describe a little bit the demo in the outside. You can see your lighting. And also, we have a power supply that converts from AC to DC. This is a standard computer power supply. And we are using the 5 volts of the power supply as our input voltage for the board. Okay? Right now, we have here our 2 connection of the 2 channels outputs. The first one is giving around 3.6 volts, 3.7, and the second one is giving 3.2 volts. Okay, now let's do a little bit of testing and we are going to try to see what is the efficiency of our power supply works right now. So first we are going to obtain the input power we are using. So by reading on the multimeter we can see, sorry, let me connect this. Okay, in the multimeter we can see the input voltage. It is reading 4.91 volts. And on the oscilloscope we can see the red line, the red wave. We are measuring about 6.5 amps. Okay, multiplying the voltage, the input voltage and the input current give us the input power we are using from the input power supply. So this gives around 32 watts of power. Okay, now we are going to measure the input voltage of the first channel and the second channel at the same time, so that we can obtain the total amount of output power. Okay, now let's connect this here, channel 1 and channel 2. So now we can see the readings on the multimeters. Channel 1 corresponds to the first multimeter and channel 2 to the second one. At the same time, the oscilloscope is reading, the red wave is reading the channel 1 current and the green wave is reading the channel 2 current. So for the first channel we have an output voltage of 3.7 volts and an output current of 3.36 amps. Same way we have for the second channel an output voltage of 3.2 volts with an output current of 4.32 volts. Okay, multiplying these values, we have on the channel 1 an output power of 12 watts and the channel 2 an output power of 15 watts. If we add those values together, we have the total output power of the system, so which come to be around 27 watts. Now to obtain the efficiency of our power supply, we divide the output power by the input power. This matter in this This way we have 27 divided by 32. That comes out to be 85%. This means we have an 85% of efficiency. With this we reduce heating and better power consumption. So this is all for today. I thank you and